All right, let's jump right in. We're about to look at an idea that might completely change how you think about why people do the things they do. We all tell ourselves stories to explain our actions. But what if those stories are missing the point entirely?
So this really is the big question, isn't it? What's really driving our behavior? I mean, when you make a choice or react to something or fall back into that same old habit, what's the actual engine making it all happen? We've got a ton of common answers, but what we're exploring today suggests we might be looking in completely the wrong direction.
Okay, so these terms, you've heard them all before, right? Beliefs, trauma, cognitive biases. Psychology gives us this whole vocabulary to sort of narrate our lives. We say things like, oh, my beliefs made me do it, or my past experiences shaped how I reacted. And look, these are the stories we use to make sense of ourselves. They're super common, they feel useful, but here's the kicker. Do they actually explain anything? And that question right there, it brings us to the absolute core of what we're talking about today. It's about making a huge shift in our thinking, moving away from just describing behavior to actually explaining what causes it. It's the difference between telling a story about what happened and understanding the system that made it happen.
So take a look at how this breaks down. On one side, you've got psychology, which is all about description. It takes what we do and organizes it into these nice narratives and themes. It's interpretive. But then you look at the other side, the structural approach. It couldn't care less about interpretation. It's all about the underlying architecture, the nuts and bolts, the actual causal mechanics that let you predict what's going to happen next.
Yeah, let that one sink in. Structure is causal. Description is commentary. This is pretty much the main point of this whole thing. One of them tells you how it works, like the physics of the system. The other one is just commentary from the sidelines after the game is already over.
Okay, so how do we actually start using this new way of looking at things? Well, it means we have to completely flip the script on where we even begin. Because how you decide to model the problem in the first place, that's going to dictate the kind of answers you can even find.
And this just lays it out perfectly. Look at the two directions. Psychology starts at the finish line. It sees the behavior, and then it tries to work backward to kind of guess what the cause was. But the structural approach, it does the exact opposite. It starts at the blueprint, the architecture of the system itself, figures out how the mechanics work, and then sees the behavior as just the inevitable output.
So here's the bottom line. Behavior is the output, not the origin. Trying to figure out why something happened by only looking at the behavior is like trying to understand how a car's engine works by just watching it drive by. It's fundamentally flawed. Behavior is just what comes out at the end. If you really want to understand it, you have to look under the hood at the engine's design.
So, what's the big payoff for thinking this way? Well, it leads to a massive advantage, the power of prediction. And this, right here, is where a structural model really flexes its muscles and shows why it's so much more powerful than just a description.
Just look at the difference in these statements. On the left, you've got these vague correlations, right? Attachment issues affect relationships. Well, yeah, sure, it describes a pattern we see. But now look at the right. These are concrete mechanical predictions. Not just that something will happen, but how a system will deform under load, or when a specific threshold will be triggered. We're moving from general tendencies to specific points of failure.
And that's really the key takeaway here. Structure reduces uncertainty. Description just increases interpretation. One path gives you more and more stories, more ambiguity, more room to guess. The other one gives you concrete, testable predictions that actually make you more certain about what's going to happen next. It's a huge difference.
Now, to make those kinds of predictions, you can't use the same old words. You need a totally different language. We have to move away from these symbolic labels and start talking in a way that sounds a lot more like, well, physics. We're talking about real mechanisms, not just convenient metaphors.
Think about a word like motivation or belief. From this structural point of view, these aren't real things that do anything. They're just symbols. They're labels we stick on a behavior after it's already happened. They're part of the description, but they're not part of the machinery that actually produced the action in the first place.
But now, contrast that with these structural mechanisms, words like load distribution or threshold activation. These aren't just labels. These are terms that describe actual physical-like processes. You can measure them. They are quantifiable dynamics inside a system that directly cause an outcome. It's basically the physics of how we think.
Okay, so why is this so important, especially right now? What's the big deal? Well, as we try to build and understand more and more complex systems, and yeah, I'm talking about AI, this way of thinking, this structural lens, becomes absolutely essential.
Because this is where a structural model really shines. Look, when a system gets super complex, our neat little stories just fall apart. They can't handle it. But a structural model, it can predict exactly where that system will fail when you put it under stress. It can map out how a conflict is going to spread along the system's fault lines. It explains why something might suddenly collapse when it hits a certain threshold. The more complicated things get, the more you need to understand the structure.
And this just nails the point home for AI. You can't program motivation. It's too fuzzy, it's a story. But you can absolutely 100% program a threshold, a specific numerical point where the system changes what it's doing. See the difference? That's the gap between a nice philosophical idea and a cold, hard engineering problem.
And this leads to a pretty huge, bold claim. This whole structural model isn't just another way to think about people. No, it's being put forward as the only real way to build a synthetic mind. It's the essential blueprint, the only epistemology that can actually bridge the gap between biology and computation.
So, as we start to wrap this up, what does all of this mean? It means we have to change the most fundamental question we ask when we see some behavior and we want to understand it.
You see, the old way, the psychological way, always asks, why did this happen? It's backward-looking. It sees something that's already done, and then it tries to build a story to explain it after the fact.
But the structural question is completely different, and honestly, a little bit radical. It asks, how could it not have happened? It sort of implies that the outcome was inevitable. It looks at the system's design, the forces at play, and asks, given all of that, was any other result even possible?
And that's the final, really provocative thought we're going to leave you with. Given the architecture, how could anything else have happened? If our behavior is just the output of our internal architecture, dealing with whatever pressures it's under, well, then it forces us to see our actions in a new light. Maybe they're not these mysterious choices we're making, but just the inevitable results of a system doing exactly what it was built to do. Kinda makes you think, doesn't it?